Today I'd like to walk you through 5 problems of how to multiply rational expressions. In this first example, you can see that the instructions tell us to simplify and state the excluded values. Simplification actually has 2 parts. In most of these problems, you're going to notice that they're all set up as fractions. That's what makes them rational. But they also include polynomials. Numbers 1 and 2 deal with monomials. But if you have a binomial or a trinomial, I want you to start the problem by factoring first. So, in my first step, simplifying monomials, I don't have to factor. These are already in simplest form and I don't need to do anything to them. So step number 2 is going to be to state the excluded values. Where do excluded values come from? We're going to look at the denominators. And if the denominator includes a variable, we're going to take that denominator and we're going to set it not equal to 0. So why do we do this? We do not want either one of these denominators to turn into a 0. If we have a 0 in the denominator, that fraction becomes undefined, and I cannot solve this problem. So, in order to find out what values to exclude, we take the denominator that involves a variable and we set it not equal to 0. And we solve it. In this case, m cannot equal 0. If I put a 0 in here and I multiplied it by 4, I would get 0 in the denominator, and I can't have that. After you've determined what your excluded values are going to be, then I want you to go back and I want you to look for things that can reduce or cancel. You're allowed to cancel and reduce top to bottom. This also includes diagonally. When it comes to variables, remember that these exponents tell you how many you have of each of these variables. So m squared means that you actually have 2 m's, m times m. So if I'm canceling my variables, we can use the subtraction property, but I think it might be easier to just think about it this way. If I take this 1m, I can cancel out one of these m's, and it's going to leave an m in the numerator. Now, when it comes to the numbers, remember, I can cancel top to bottom, or I can cancel diagonally. It's totally your choice. Just make sure that you cancel out everything that can cancel. I'm going to start with the 9 and the 6. They're both divisible by 3. 3 will go into 9 3 times, and 3 will go into 6 twice. Now, I could cancel the 4 with the 10, or I could do 2 with 10. Either one will work. I only am going to choose one of those options, though. I'll do the 2, divides into the 10, leaving 5. Now remember, when part of our problem completely goes away, it's not gone like 0. When everything cancels out, it still leaves a 1 in that location. Now that I have canceled or reduced everything that I can cancel, I'll go ahead and do my multiplication. Multiplication is straight across, numerator times numerator. So 3m times 5 is 15m. In the denominator, I have 4 times 1, which is 4. Before I circle or box my answer, I'm going to check it one more time just to make sure that I didn't miss something that could have canceled or reduced. Since 15 and 4 have nothing in common, I'll go ahead and box my answer. This second problem is the same as the first example. Everything is a monomial, so I don't need to factor. I'm going to go ahead and identify my excluded values. I don't need to worry about the first denominator because there isn't a variable in it, so I'll focus on the second denominator. 10 x to the 4th cannot equal 0. I would divide by 10, so I get x to the 4th cannot equal 0, and I would take the 4th root of both sides. X cannot equal 0. Now that we have determined our excluded value, let's go ahead and look for things that can cancel. I can see that 2 will divide into 2 one time and into 10 5 times. I don't see any other numbers that can cancel or reduce, so now I'll focus on my variables. Remember, these exponents represent how many you have of each variable. So I'm going to take these 2 x's and I'll cancel out 2 of these, and it will leave x squared in the denominator. I'm not done, because this single x can cancel out one more x, leaving a single x in the denominator. Now, to write my answer, I'll multiply everything that remains in the numerator, 1 times 3, and I'll multiply everything that remains in the denominator. 5 times 5 times x is 25x. In number 3, we introduce binomials. So now we're going to talk a little bit more about factoring. I told you at the beginning that simplification actually comes in 2 phases. The first is to factor everything before you state your excluded values. And then the second step for simplification is to cancel and see what remains. So I'm going to go piece by piece. This first numerator is a monomial. I can't factor monomials, so I'm going to leave this just like it is. This denominator, x plus 3. When I have binomials, there are 3 questions I want to ask. Do these 2 terms have something in common? No. Second question, is this the difference of 2 perfect squares? Nope. And my third and final question, is this the sum or difference of 2 perfect cubes? No. If you answer no to all 3 questions, I want you to put parentheses around this binomial. The reason we do this is because these 2 terms cannot be separated or canceled individually. So the only way I can cancel this binomial is if I have another x plus 3. It's all or nothing. Next binomial, x plus 5. Do they have something in common? Nope. Are they the difference of 2 perfect squares? Nope. Is this the sum or difference of cubes? No. Let's put parentheses around this one also. Final binomial, x squared minus 9. Do they have something in common? No. Is it the difference of 2 perfect squares? Yes. So let's factor it into 2 parentheses. X plus 3, x minus 3. Once you factor, you can cross out that original binomial because you no longer need it. Now that everything is factored, let's state the excluded values. Remember, excluded values only come from the denominators that have variables in them. I actually have 2. I'll take x plus 3, set it not equal to 0, and solve. So my first excluded value is x cannot equal negative 3. Now I'll do the same with x plus 5. My second excluded value is negative 5. Now that I've stated my excluded values, I'll go back and I'll cancel things that are the same or that can be reduced. Remember, when it comes to parentheses, it's all or nothing. I can cancel this x plus 3 with the 1 on top, but I don't see anything else that can cancel. Remember, when you cancel out a numerator or denominator entirely, it doesn't go away, it just becomes a 1. So now, in the numerator, I have 1 times x minus 3. And in the denominator, I have 1 times x plus 5. As far as the parentheses, you could write this problem without the parentheses, but I'm going to encourage my class to keep the parentheses on so that they are not tempted to cancel out the individual parts. Remember, when it comes to binomials, it's all or nothing. Parentheses help remind us of that. Number 4 has a good mix of monomials and binomials. You can see both parts of this first fraction are monomials, so I can't factor either one. I'll go to the top of the second fraction. What do these two terms have in common? Always go with the biggest number that can divide into both of them, and in this case, it's 21. If I divide 21 into each of these, I'm left with n plus 1. Now I'll go to the denominator. What do these two terms have in common? 30n. When I divide 30n into each of them, I'm left with n plus 1. Now that everything's factored, let's look for our excluded values. Remember, I don't need to worry about this first denominator because there isn't a variable in it. I will have two excluded values. If I take 30n and set it not equal to 0, then my first excluded value is 0. n plus 1 not equal to 0. My second excluded value is negative 1. Now that I've stated my excluded values, let's go back and look for things that cancel. N plus 1 can cancel out with n plus 1. Now I'm left with all monomials. With monomials, you can cancel the individual parts. So I can cancel the 7 with this 7. I can also cancel this n with the n down here. Remember, when everything cancels out, it's not 0, it's 1. The last thing that can cancel is the 21 and the 30. What do they both have in common? They're both divisible by 3. So I'm left with 7 over 10. Now for my final answer, take everything in the numerator that is left and multiply it together. 1 times 7 is 7. Do the same with the denominators. 1 times 10 is 10. Since this cannot reduce any further, 7/10 is my final answer. In this last example, we're adding a trinomial. You're going to see a lot of similarities between this problem and the previous problems. When we start off, we want to factor the trinomial by asking, do these three terms have something in common? And they do. They're all divisible by 3. After you've factored out the 3, you no longer need the original problem. But you're not done. You need to ask yourself if this trinomial can factor into 2 parentheses. Are there 2 numbers that can multiply to give you a positive 8 that when you add them will give you a positive 6? Yes, positive 2 and positive 4. Now let's go to the denominator. Do these 2 terms have something in common? Yes, they're both divisible by 6a. When I do that, I'm left with a plus 2. (5a minus 3). Do these 2 terms have something in common? No. Are they the difference of 2 squares? No. And is this the sum or difference of cubes? No. If you answer no to all 3 questions, put parentheses around this binomial. Final binomial. Do these 2 terms have something in common? Yes. Make sure that you go with the largest number that can divide into both of them, 8. And they both have an a squared. When you divide 8a squared into each of them, you're left with 3 minus 5a. Now it's time to do our excluded values. I talked about before that when you have monomials, we already know the excluded value is going to be 0. So both 6a and 8a squared, when I solve them, I'm going to get that a cannot equal 0. There is no need for you to write that answer down twice. Now, the a plus 2 If I set that not equal to 0, then I find that a cannot equal -2. And then finally, I have 3 minus 5a. When I set that not equal to 0, I'll subtract 3 and then divide by -5. So a cannot equal +3/5. After you've done your excluded values, let's look for things that can cancel. Remember, when it comes to your binomials, your parentheses, it's all or nothing. So I can cancel a plus 2 with a plus 2. Monomials, I can cancel the individual parts. So this 3 can cancel with this 6, leaving 2. Looking very closely, it doesn't look like I have anything else to cancel, but I'm going to show you a trick. If you notice that 2 of your parentheses have the same exact numbers, but the only problem is that your signs are the exact opposites, you can fix this. Here's what you need to do. If you will divide out a -1, you will be changing the sign of both of the numbers inside the parentheses. And now, this parentheses is the same as the one below, and they can cancel also. Now that we've canceled everything that we can, we'll take what's left in the numerator and multiply it together. I've got a -1 and I have a plus 4. In the denominator, I have 2a and I'm going to multiply it with 8a squared. When I do that, I get 16a cubed. Again, you have the option of distributing the 1, which is perfectly fine, or you can leave it separated and factored. Just be careful. Don't cancel things that are part of a binomial. If you do choose to distribute the 1 and you get -a minus 4, just realize that this 4 cannot cancel with the 16 because this 4 is part of a binomial and the denominator is a monomial.